Hi guys, let's look at the homework questions of exercise 7b. But before we start, let's quickly revise what we've done in this exercise. So first thing we started what four non-zero numbers a are said to be in proportion if a is to b is equal to c is to d, which means a upon b is equal to c upon d. This is in the fraction form, which means AD is equal to BC. A and D are the extremes and B and C are the means. Perfect. These are non-zero. Now, three non-zero terms are said to be in continuous proportion if A is to B is equal to B is to C. If I write it in the fraction form, that will be A upon B is equal to B upon C, which means B square is equal to AC. Now, B is the mean proportion. And we can also look at this method, which is A upon B is equal to C upon D is equal to K. Let's introduce a constant or is equal to K. Similarly, A upon B is equal to B upon C is equal to K. Let's introduce a constant, which means A would be equal to BK, B would be equal to CK. If I put B value here, A would be equal to CK square. Perfect. So these are the couple of things that we've done in this exercise. Let's go ahead and solve the homework questions. So the first homework question was question number 1, part 2. It says find the fourth proportional of 3a, 6a square, 2ab. So let the fourth proportional be x. So what we have is product of extremes, which means 3a into x would be equal to 6a square into 2ab square, which is product of means, which means a or rather x, that's what we need to find, would be equal to 6a square multiplied with 2ab square divided by 3a. A and a gets cancelled, 3 1 3 2, which means 2 into 2, that's 4, a square b square. So that's our answer. The fourth proportional is 4a square b square. Good. Let's look at question number 2, part 2. It says find the third proportional. So let third proportional be equal to x. So what we have is a minus b upon a square minus b square is equal to a square minus b square upon x. Yes, that's the correct one. Now what I can do this as a minus b. A square minus b square can be written as a minus b multiplied with a plus b, and this is equal to a square minus b square upon x. So a minus b in the numerator and denominator gets cancelled, which means x is equal to, let's cross multiply. So what we get is x is equal to a plus b multiplied with a square minus b square. So our third proportional is a minus b, or rather a plus b multiplied with a square minus b square. Good, let's look at the next question. The next question that we are doing is question number 3, part 2. It says find the mean proportional between a minus b and a cube minus a square b. So let mean proportional be x. So what we have is x square should be equal to a minus b multiplied with a cube minus a square b. Now this is a minus b. Between these two terms, I notice a square is common. So let's take a square common. What remains is a minus b. So this is equal to a square multiplied with a minus b whole square. That's the value of x square, which means x would be equal to square root of a square multiplied with a minus b whole square, which means plus minus out of a square, a comes out of a minus b square, a minus b comes out, which means the value of x would be plus minus a times a minus b. That's the mean proportion. Let's look at the next one, which says x square, 4, 9 are in continued proportion. Find the value of x. So since they are in continued proportion, which means 4 square should be equal to 9 into x square. I hope you remember a is to b is to c, which means A upon B is equal to B upon C, which means B square is equal to AC. That's exactly what I've done. In this case, B is 4, A is x square, C is 9. What we get is x square is equal to 4 into 4 upon 9, which means x is equal to square root of 16 upon 9. Therefore, x is equal to plus minus 4 upon 3. That's our final answer. The value of x could be plus minus 4 upon 3. Right? But will it be, if I take the value as negative, will it work? Yes, it will work. We'll have x is equal to plus minus 4 upon 3. Let's look at the next question. The next question that we do is question number 7, part 2. It says A, B, C are in continued proportion and A times B minus C is equal to 2B. We need to prove something. Okay, so A upon B is equal to B upon C is equal to K. So let it be equal to K. What we get is A is equal to BK, B is equal to CK, which means A is equal to CK square and B is equal to CK. These are the values that we can substitute. What else is given is A times B minus C is equal to 2B. Now let's substitute values. A is CK square, B is CK minus C is equal to 2B. B in this case is 2 times CK. Yes, that's correct. And let's see what do we have. So between this C is common. So I take out that C common. What remains is K minus 1. Yes, if I take C common from here, the first term K remains, second term 1 remains. This is equal to 2 times Ck. C and C gets cancelled, K and 1 power of K gets cancelled, which means Ck times K minus 1 is equal to 2. Let's call this equation 1. Because this is given, I am assuming and hoping that this will be useful to us when we are trying to prove left hand side equal to right hand side. So let's start working with the left hand side. Left hand side is A minus C. Let's substitute values. A is equal to CK square, C is C, which means this is equal to C times K square minus 1. Right, that's the value of left hand side, C times K square minus 1. Now let's work with the right hand side. So right hand side is 2 times A plus B upon A, which means 2 times A. A is equal to CK square, B is equal to CK, A is equal to CK square. Between CK square and CK is common. So let me take out CK common. So this is 2 times CK and what remains is K plus 1. In the denominator, we have CK square. Let's cancel C. Let's cancel 1 power of K. And what we have is 2 times K plus 1 upon K. Yes, 2 times K plus 1 upon K. Now, I is still not equal to left hand side. So what do we do? Well, I notice that equation 1 gives me the value of 2. So let's put the value of 2 in this equation. Let's call this equation 2. So put 1 in 2 and what we get right hand side is equal to 2. Instead of 2, I will put Ck times K minus 1 and this is K plus 1. And in the denominator, I have K. All I have done is I have just replaced the value of 2 as Ck times K minus 1. So Ck times K minus 1 is 2. What remaining here is K plus 1 upon K. This K and this K gets cancelled. So this is equal to C times K minus 1 times K plus 1, which is equal to C times K square minus 1. Yes, x plus y into x minus y is x square minus y square. This is equal to right hand side. So I notice now that my left hand side and right hand side are equal. Left hand side was C times K square minus 1. Right hand side is C times K square minus 1. So from 8 and 15 we have therefore left hand side is equal to right hand side is equal to C times K square minus 1. Hence proved. Done. Let's look at the next question. The next question that we do is question number 8. Question number 8 says, what least number must be subtracted from them so that they are in continued proportion? So let x be subtracted. So what we have now is 7 minus x upon 17 minus x would be equal to 17 minus x upon 47 minus x. Let's cross multiply. What we have is 7 minus x multiplied with 47 minus x is equal to 17 minus x the whole square. So 7 into 47, that's 280, and 49. So 329 minus 7x minus 47x plus x square, 17 square, that's 289 minus 17 into 2, 34x plus x square. X square and x square gets cancelled. So what we have is 329 minus 289 would be equal to negative 34x plus, when I take these two on the other side, that's negative 54. When it goes on the other side, becomes plus 54x. 329 minus 289, that's 11 and 29, which is 40, is equal to 20x, which means x is equal to 2. So the answer is, therefore, 2 has to be subtracted from all of these given numbers to put them in continuous proportion. Good, let's look at the next one. The next one that we are doing is question number 9. It says, if y is the mean proportion between x and z, show that xy plus yz is the mean proportion between. Okay, so what's given is x is to y is to z, which means y square is given equal to xz. That's what's given. Now what do we have to prove? We need to prove that this is the mean proportion, which means xy plus yz to the power 2, which means the whole square, is equal to the product of the first term and the third term, which is x square plus y square multiplied with y square plus z square. Right, so if this is the mean proportion, then the square of the mean is equal to the product of the remaining two terms. So let's start with the left hand side. So left hand side, we have xy plus yz the whole square. Now this will give us, between xy and yz, we have y common. What remains is x plus z and everything to the power 2. Yes, xy plus yz, y is common. If I take y out, first term is x, second term is z, and it is z, everything whole square. Which means this is equal to y square times x plus z the whole square. If I take power 2 for y separately and power 2 for x plus z separately, y square we know is equal to xz. So xz times x plus z the whole square, since y square is equal to xz. So what we now have is left hand side is equal to xz times x plus z the whole square. Let's see if we can prove right hand side equal to the same thing. Let's try. So right hand side now, what we have is x square plus y square. So x square plus y square multiplied with y square plus z square. Now x square is obviously x square, y square is xz, y square is xz, and z square is z square. Reason, since y square is equal to xz. That's the only thing I have replaced. Next, between these two terms, I notice x is common. So if I take x common, what remains from this first bracket is x plus z. Between the terms in the second bracket, z is common. So if I take z common, what remains is x plus z. So what we get now is xz multiplied with x plus z the whole square, and this is equal to right hand side. So from point number 7 and point number 9, or point number 11 rather, we have left hand side equal to right hand side, which is equal to xz times x plus z the whole square, hence proved. So we've been able to prove left hand side and right hand side are equal, which means that's what the question was. Good. Let's look at the next question. The next homework question was question number 12. It says y is the mean proportion between x and z, which means x upon y is equal to y upon z, basically meaning y square is equal to x z. Next, we need to prove the left hand side is equal to right hand side. Now let's start working with the left hand side and see what do we get. So that's x square minus, instead of y square, let me put xz plus z square. That's all I have done. And in the denominator, we have x to the power negative 2, which means 1 upon x square minus 1 upon y square plus 1 upon z square. Right, so this is x square minus xz plus z square, everything divided by 1 upon x square minus 1 upon xz plus 1 upon z square. All I have done is I have replaced the value of y square with xz. This gives me x square minus xz plus z square, and in the denominator let's take the LCM and let's add or subtract them. LCM of x square, xz and z square would be x square z square. So this would be, the first term would be z square. Yes, the second term will be xz and the third term will be x square. Now this is first term divided by second term, so this will become x square minus xz plus z square multiplied with x square z square divided by z square minus xz plus x square. I notice that these two terms are exactly the same, so they get cancelled. So what is on my numerator is x square z square. I can also write this as xz the whole square. But I know xz is nothing but y square. Yes, so this is nothing but y square to the power 2. Reason, since xz is equal to y square. So I've just replaced value of xz with y square. This gives me y to the power 4, which is equal to right hand side. Good, that brings me, you can put a small star on this question, quite an interesting question. That brings me to the last homework question. The last homework question was question number 15. It says find the third proportional to x upon y plus y upon z. So that's one term and root of x square plus y square. So let's first figure out what the first term is. It's x upon y plus y upon x. Let's take the LCM. The LCM is xy. So this is x square plus y square. So what we need to figure out is the third proportional. So let the third proportional be A. What we have is x square plus y square upon xy is to square root of x square plus y square is to b, or not b, a. We've taken the variable a. They need to be in a continuous proportion, which means the square of the second term, in this case the square of the second term, should be equal to the multiplication of the first term and the third term. In this case, x square plus y square upon xy multiplied with a. Right. Let's see what we get. When I square this first term, this becomes x square plus y square, and this is x square plus y square upon xy into a, which means the value of a is equal to x square plus y square multiplied with xy divided by x square plus y square. X square and y square gets cancelled, therefore a is equal to xy. Therefore, third proportional is xy. That's our final answer. Perfect. That brings me to an end of this video and of this exercise. Take care, be safe. If you have any questions or queries, feel free to write into me. Thank you so much. Bye-bye.